Alright, so we're looking now at section 2.4. We're going to talk about dividing polynomials and the remainder and factor theorems. So here are the things that we're going to learn to do. We're going to use long division to divide polynomials, use synthetic division to divide polynomials, evaluate a polynomial using the remainder theorem, and use the factor theorem to solve a polynomial equation. So let's jump right in. Alright, how do you divide a polynomial by another polynomial? Well, you can perform long division as you do with numbers. Remember, division is just repeated subtraction, so each time you have a new term, you must subtract it from the previous term. Work from left to right, starting with the highest degree term. You want to make sure that both of your polynomials are written in descending order, from left to right, largest degree on the left, and just with numbers there may be a remainder left. The divisor may not go into the dividend, the thing underneath the house, evenly. Alright, so let's divide this using long division, and then we're going to state the quotient, q of x, which is the answer to the division problem, and the remainder, r of x, if it has one. So we're going to do 3x plus 4 on the outside, and inside we're going to have 6x cubed plus 17x squared plus 27x plus 20. Now all you're asking here is the same exact thing. Let's say we were dividing 13 into 47. Or let's go ahead and say 476. If we were dividing this, we would say, how many times will 13 go into 47? And that's going to be 3 times. Another way to ask that exact same question is, what times 13 is going to give me something really, really close to 47? And that would be 3. So that's going to give me 39 here. When I subtract, I'm going to get 8. And then you bring down the next part. Notice that we do subtract here. So we bring down the next part and we ask the exact same question all over again for 86. How many times will 13 go into 86? Or what do I multiply times 13 to get something as close to 86 as I can? And you would keep going through that. With that one, let's see, 4, no, 5 would be 85? Yeah. No, it wouldn't. It would be 65. 6, 8 is 68. 7 would be 91, though. Okay. So it's going to be 6. So that's going to give you 18 here. Carry the 1. That'd give you 78. And then, of course, you'd have a remainder of 8. Now, if you remember, the way we wrote that was we wrote it as 36 or 8 when we first started. And what a lot of people forget is there was a step right after that, before you got into the adding zeros over here and continuing and finding the decimal values. You actually took this and you said 36 and you put the 8 over the 13. Well, guess what? That 8 over 13 is going to be exactly the same value as what your decimal is that you're going to find there. So the remainder over the divisor gave you the actual remainder, how much was not divided in, or gave you the rest of the answer. So we're going to look at how to do that as well. But let's go ahead and we're going to ask, what do I multiply times 3x to get 6x cubed? Well, we know we're going to multiply by 2. 2 times 3 gives me 6. What do I multiply times x to get x cubed? Well, it's going to be x squared. So 2x squared times 3x gives me 6x cubed. If these two things right here do not match exactly, you're doing something wrong. Alright, and then you're going to take that exact same thing, the 2x squared, and multiply it times the plus 4. So you're going to get 8x squared. Put parentheses around it and subtract. If you do not put parentheses around it, you're going to subtract the 6x cubed and you're going to add these over here. But it should be 17x squared minus 8x squared, which is going to give you 9x squared. And then bring down the next term. Alright, and then guess what? Same thing as we did over here. Go through the exact process again. What do I multiply times 3x to get 9x squared? 3x. 3x times 3x gives me 9x squared. 3x times 4 gives me plus 12x. Parentheses and subtract. 9x squared minus 9x squared gives me 0x squared. If these don't cancel out, you've done something wrong. And then 27x minus 12x is going to give you 15x. And bring down the next term. And go through the process all over again. What do I multiply times 3x to get 15x? That would be 5. And 5 times 3x gives me 15x, which is what I'm looking for. And 5 times 4 is going to give me plus 20. And then parentheses, subtract. 15x minus 15x goes away. 20 minus 20 also goes away. So we have no remainder here. That means that 3x plus 4 goes in evenly into that polynomial. So our q of x is equal to 2x cubed plus 3x plus 5. So 6x cubed plus 17x squared plus 27x plus 20 divided by 3x plus 4 equals 2x cubed squared, 2x squared plus 3x plus 5. Alright, so let's do this one. So we've got 2x minus 1 dividing into 4x squared minus 8x minus 8x minus 8x plus 6. So going through the same process, 2x, what do I multiply times 2x to get 4x squared? That'll be 2x. 2x times 2x gives me the 4x squared I'm looking for. 2x times negative 1 gives me minus 2x. Parentheses, subtract. 4x squared minus 4x squared goes away. Negative 8x minus a negative 2x, that's the same thing as adding 2x. So you get negative 6x. Bring down the next term. What do I multiply times 2x to get negative 6x minus 3? Negative 3 times 2x gives me negative 6x. Negative 3 times negative 1 gives me plus 3. Parentheses and subtract. So negative 6x minus a negative 6x cancels out. 6 minus 3 gives me 3. So I have a remainder on this one. And you could write it as 2x minus 3 and put R3. Now the other way that you can do this is you can write it much like that fraction thing we were talking about, and to write the entire quotient that includes everything, you would do 2x minus 3 plus remainder over divisor. So plus 3 over 2x minus 1. So there is your extra parts that did not divide out evenly. So here, this is your q of x, and this is your r of x. This is just the quotient. That's just the answer to the problem completely, including the remainder. The remainder is included in your answer. Alright, now remainders can be useful. The remainder theorem states that if the polynomial f of x is divided by x minus c, then the remainder is f of c. Now, don't just read that and not let that kick in. What this says is this: if you divide by x minus 2 and you evaluate f of 2, the remainder of this thing is going to be equal to what you get when you plug 2 in to the polynomial. That's what that says. The remainder is nothing more than the function evaluated at that value right there. Now don't lose the process of the minus here. That means whatever you pull out, you're going to change the sign. That's why it's minus 2 here, but positive 2 here. So when you pull it out, you've got to change the sign. But that's going to be true. So if you can quickly divide, this provides a nice alternative for evaluating f of c, or if f is something that you can easily plug into, but might be difficult to divide, it makes it a little easier to just evaluate the function. Not only that, but if f of c equals 0, what do we know? That's an x-intercept. So if you're looking at the graph, what do we know? We're going to have remainders of 0 for all of the values where the graph is going to hit the x-intercept, or the x-axis. But we'll talk about that in future sections. All right, now let's talk about synthetic division. It's a quick method of dividing polynomials. It's used when the divisor is of the form x minus c. You cannot use it when your x has a coefficient other than 1 in front of it. And the last column, the bottom of the last column, will always be the remainder. All right, so to do synthetic division here, we're going to take this and we're going to solve it for x. So x minus 1 equals 0. We're going to move the 1 over. So x equals 1. That is what goes in your box right here. And then you're going to write out the coefficients only of this polynomial that we're dividing into. 1, 0, 1, negative 2. Now, some of you are probably wondering, well, where does 0 come from? You have to have a place for all of your powers. So this 1 comes from the x cubed. I have no x squareds. That's where my 0 comes in. I have 1x. That's where that 1 comes in. And my constants are minus 2. All right, and then you're going to draw a line down here, leave enough that you can write numbers in here. And I always go over here under my last column and just draw 2 little lines like this to separate my remainder from the rest of the stuff. So what you're going to do is you're going to bring this number down, and then you're going to multiply this times that and put it right here. And then you're going to add, not subtract. Alright, so what I did here, brought the 1 down, multiplied that 1 times there, put it right here, added 0 plus 1 and got 1, multiplied that 1 times 1 and put this 1 in. 1 plus 1 gives me 2. 2 times 1 gives me 2. Negative 2 plus 2 gives me 0. So this one actually has a remainder of 0. So x minus 1 divides evenly into x cubed plus x minus 2. Now, what's my answer? Well, here's the neat part. From here over, you're just going to build that answer. This is your constant. It's a positive. This is the coefficient for your x. This is the coefficient for your x squared. So this comes from that one, that comes from this one, and that comes from this one. I always build it from the remainder over. And it's increasing in powers. Don't jump up and make this x cubed or anything like the original problem. These columns are literally starting constant, x, x squared, x cubed, x to the 4th. If anything was there, you'd put those terms in. All right, let's do another one. All right, so we've got x minus 2, and if I solve that, I'm going to get a positive 2. I'm going to put that in my box over here. And then I'm just going to write this in descending order of the coefficients only. So 1, negative 2, negative 1, 3, negative 1, and 1. 1, negative 2, and I usually space them out just a little bit just to keep them separate. Plus 3, I don't need the plus though, I'm going to move that over a little bit, minus 1, and positive 1. So just to double check, 1, negative 2, negative 3, negative 1, positive 3, negative 1, and 1. Always double check, especially if you're in a hurry or get distracted, because I mean it's real easy to write down the wrong thing when you're writing all this stuff down and then do everything completely right, but guess what? You just did the wrong problem, so you got the wrong answer. Alright, so let me change colors here just so you can see what I'm going to... So this is just the setup, and then I bring that down. 1 times 2 gives me 2. I add those, I'm going to get 0. 0 times 2 gives me 0. Add those, I get negative 1. Negative 1 times 2, I'm going to get negative 2. Add those, I'm going to get positive 1. 1 times 2, I'm going to get 2. Negative 1 plus 2, I'm going to get 1. 1 times 2, I'm going to get 2. Add those, I get a remainder of 3. Alright, so now to build my quotient, I start here with my constant, my x value, both of those are positive. My x squared is negative, so I put the negative out in front. I have no x cubed, and then I have an x to the 4th, so that's positive. And your remainder is 3, or you can always go back and rewrite it the fraction way, so it would be plus, since it's a positive 3, 3 over the divisor, and what was the divisor? X minus 2. Sure how I magically changed from red to blue, but anyway, so that's synthetic division. Just a little quicker way as long as you've got a linear divisor. Now, the factor theorem says that if f of x is a polynomial, it says f of x is a polynomial, therefore f of c equals 0 if and only if x minus c is a factor, and factor means it's going to divide in evenly, of f of x. In other words, if f of c equals 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c equals 0. What this translates down to is that if we know a factor, we know a 0. Or, if we know a 0, we know a factor. The two things are kind of interchangeable. I mean, granted, they're not exactly the same. Here it's just a number we're plugging in. Here it's actually a factor. But here's the thing. If we take this, we're saying x equals c. What happens if we set that thing and make it equal to 0? We're going to move it to the other side and get x minus c equals 0. Oh, look at there. Alright, so if f of x is a polynomial and c is a number such that f of c equals 0, we say that c is a 0 of f of x. Now, we're talking here mostly algebraic, but think graphically as well. If f of c equals 0, that means that it's touching the x-axis, if we looked at the graph of that when x equals c. So the following two things are equivalent ways of saying the same thing. C is a 0 of f of x. X minus c is a factor of f of x. And you could even add in there x equals c is an x-intercept of f of x. So we can kind of start thinking about the graphical ways too. So all three of these things are the same thing. All right, so use the remainder theorem to find the indicated function value. Now remember, the remainder theorem says whatever the remainder is when we divide in x minus 3 in this case into this polynomial, is going to be this up here on top. Oh, sorry, the remainder is going to be equal to f of 3. And I'm going to show you this, but I just want you to know that's what we're doing. Now, I'm not going to do it long division. I'm going to go ahead and do it synthetic since it'll be a little quicker. So we've got 3, and we've got 1, negative 7, 5, and negative 6. So bring the 1 down, 3, negative 4, negative 12, negative 7, negative 21, negative 27. So the remainder here is negative 27. That's also what f of 3 is going to be. Now I'm going to prove that. So f of 3 just means we're going to plug 3 in everywhere we've got an x in here. So we're going to have 3 cubed minus 7 times 3 squared plus 5 times 3 minus 6. Now let's simplify. We got 3 cubed, that's going to be 27. Negative 7 times 3 squared, well 3 squared is 9, so that's going to be minus 63 plus 15 minus 6. Now I'm going to go ahead and put all the positives together and all the negatives together just to make it one subtraction thing. So we've got 27 plus 15, that's going to give us 42. And then I put my minuses together, I'm going to get minus 69. So remember, when you're adding things that are opposite signs or subtracting like this, we're going to do 69 minus 42. I'm going to do this over here to the side. And I know it's 42 minus 69, trust me here. But you're going to do the 69 minus 42, and the answer is going to be negative. So you're going to have 7 there, and 2 there, and the answer is negative. So we end up with negative 27. Hey, it's not a coincidence that these two numbers are the same thing. That is the remainder theorem.